Let's try it now. I'm betting everyone can hear me. Let's start over. Okay, we're like 3 minutes in. There was no sound. So let me go ahead and add that in the comments. Mike was off. First 3 minutes. Okay, there we go. We'll add that to the description. That way everyone knows what's going on. Okay. Perfect. Everyone can hear me. So first, before I get into everything, let me repeat what I had said at first. This is the 100 subscriber giveaway. Now that I have sound, I can't talk. Any of the equipment that you see, any of the equipment that I show, any of the brands that I show are not affiliated with me in any way. This is very simply, this is all, everything I purchased with my own money. No one's telling me or paying me to say anything. It's all me. So whatever you see here today, those companies are not affiliated with me. So with that out of the way, let's talk about what's in the giveaway. So what I'm going to do is I'm going to do the giveaway. We're going to give away two of these to two people. Please focus. And those are the Roaring Top 850 milliamp ADC 14.8 volt batteries. Now, these LiPos are cool. I like these. Definitely for smaller drones, but I thought I was going to give like one away, like give away 4, to like 4 people. And I thought that's not a great idea. So let's do 2 per winner. We'll have 2 winners. That way, at least you can swap one out, well, when you go out and use it. And you may already have like a plethora of batteries anyway, but the idea is that you guys have been with me since sort of the beginning of the journey. So I appreciate that. And there was a lot of people that said, nah, this is crazy. Why are you using EDFs for this? Why? Well, because I can. I wanted to. That's the whole idea. There is a project. There is a overarching concept that I'm going for. These are just stages. And on one of the stages, I went to the point, was at the point where I had designed this monstrosity over here. Hold on one second. This is a fun one. Okay. You can kind of see how the idea was. Go with 70 millimeters. Let's get the motor mounted, and it would basically pitch down, and I'd have my my yaw control as a fin in there. But it was more of a triocopter design, and I went about it a crazy way. So I had a pusher on the bottom. So I kind of kept the old ones that I was working. So the idea behind that one was that I was going to be able to control it by servo, which is what I originally designed it as. And actually it did work as far as the servo control and things of that nature, using your ailerons in the same fashion as you would on control surfaces for an aircraft, but with sort of downward facing thrust. The problem was I wasn't using any kind of flight controller. I was doing it old school, like I used to, where it was just receiver, ESC, and the motor, the battery. That was it. There was no stabilization. So it was almost impossible to get it to sit in the air, to get it off the ground, and to get it to sit in the air and run stable. So that one never really got off the ground. I think it could using a flight controller, like a Speedy B F405 wing. And that's something that I'm going to attempt next with that design, but we're still working on the EDF concept. I had never used iNav before any of this or any of the other flight controller programming softwares. So it was always new to me. All of it was new to me. And I designed pretty much everything in Fusion. So Fusion is the program I use, the CAD program I use. And I tried to stay with solid modeling because I figured mesh, yeah, that would be great for doing airfoils and things like that. But you can still get a lot of good type of rounded T splines and airfoil designs out of solid body modeling, as opposed to having to switch over to mesh and all that other stuff. Yeah, Steve, that's right. That's exactly right. I didn't get out of the ground. I eventually went back, kind of backed up where I was going with the whole project, and decided let's just make this a standard quad X and just use the EDFs. And then, because one of the biggest issues I was running into was I was trying to incorporate too many of my design ideas, my overall design ideas, uh, before I had understood INAV and understood how EDFs react. Because you don't really see a lot of EDFs being used in INAV, and I could be wrong. There might be a whole bunch out there. I just haven't seen them yet. But when you're, and I liked the VTOL aspect of what the controller could do and INAV, but getting all that controlled for me was just getting into it was too much. So I was let's go back to the basics. Let's stay with INAV, and let's go for just understanding the PID and everything else you need to understand, the gyro filters, the I mean, when I'm running across like the settings, I'm going, what the heck is what's a unicorn factor? It's like I didn't even know that exists. I was like, this is all new to me. So I'm like, wow, this is like a whole new language. So, and then everyone's talking about, well, so you can do stuff through CLI. Well, you want me to hand code all this stuff? I've never even used INAV before. But yeah, basically the idea was to learn INAV and also make this work. Because what I did is I originally had 64 millimeter EDFs in a smaller body. If you've seen the actual videos from the beginning, I kind of tried to go from the very beginning where I started up to where I am now. And I started with 64 millimeter. It was 14.8, so it was pulling more current than the F405, the standard F405, not the wing, could handle. So it was blowing the capacitor right out of the back. I mean, it would just burn right through the wires. I was like, okay, so now I've got an overheating issue. Well, I know if I drop the KV, I drop my current. So I decided to go with 6S. Well, problem with that is what I was pulling was in 4S in the neighborhood of 340 amps constant current. There isn't, or at least to my understanding, there wasn't an ESC on a stack within my budget that was even conceivable at that time. So I had to try and get creative. So I'm using an F405 wing, and that's basically piggybacked on top of a ADB power distribution board, which is capable of 500 amps constant current, and it does have a 12-volt output on the board. So I was able to basically run power to the SpeedyB from that power distribution board to the SpeedyB's power distribution board to power it up, and then run the motor outputs from the flight controller, the ESC, or sorry, the power distribution board, from that to the motor control, just one wire, signal wire only, straight over to it. It also has a telemetry output on there. I just got to figure out where the telemetry input is on the SpeedyB. And then I've got to get away from S-Bus protocol, because right now that's what I'm using. Because again, it's a budget thing, on limited benefits. So basically, I would love to get an ELRS controller. I'd love to get an ELRS receiver, and then be able to kind of run black box logging on the SpeeDB and kind of get try to see where the problems are in my when I'm setting my LPF cutoff frequencies and the gyro filters and things like that. But it's going to take time. So, I mean, I printed everything here, even this poor monstrosity, which now has a motor that fell off again after that last encounter with the fence. My glue didn't hold as well as I thought. And there were some aerodynamic properties that I kind of needed to address. Like I wanted to have adding this lip into the on the top of the motor. I'm trying to get this where you can see it. Did help with the output thrust, but it's also creating an airfoil. You also want it to be kind of like an airfoil that goes around, not this jumbled mess. This is sort of just me experimenting like crazy. All I needed, I was very impatient with the process because I was printing on an Ender 3. So it was a matter of, okay, you've got one motor mount ready to go in 7 to 12 hours. So I decided to go with something simple. And that's when I made that original platform, where it's just more of an X quad. And then, of course, I had to use older soldering tips because I didn't have what I needed. So I literally looks like shiny soft serve on most of my solder pads, but I'm learning how to fix that. So more heat over a larger area as quick as possible to get it to pool up, and then get your iron off there and let it, cool down so you're not burning anything up or dislodging other parts of or dislodging some of the smaller SMDs by having too much heat on the board too long and causing yourself more headaches. Because the idea was I wanted to understand, let's get back on track. I wanted to understand not just how iNav functioned, but how it interpreted something with a much, much higher RPM than an EDS, or than a standard prop motor. We're talking 59,000 RPMs is what we're dealing with. So the corrections that need to be made are need to be made much faster, and they need to be made with cleaner data. So finding that happy medium between the cutoff frequencies and the overall body design was something I had to consider. So at first it was just, let's go straight for the solid body build and let everything touch one another, basically. We want the motors to be spinning. We want the oscillation from the motors to go through a complete solid body and all the way up through to the controller, so that I could see through black box logging what was going on, what frequencies I was having to deal with that may have been causing any kind of gyro issues. And then I was dealing with some motors. These are the 6S motors here. These are they're great motors, but they're just, the bearings don't. Let's see if we can get this focus. Focus. Probably go this way, huh? Focus. Okay, you probably can't read it. Hold on. Crap, even I can't read it. That's what happens when you get old. It's a 3060 2100 kilovolt 6S motor. This is a motor that I was using, but the problem was, because I originally started experimenting with the drone after I built it, after swapping the original 4S motors out, the problem ended up being is I had unbalanced propellers. My bad. So these things started making more whining noises than anything else after a while. And they started, and not to mention, I wasn't using D-Shot ESCs. I was using standard ESC protocols. So that ended up being an issue. And getting 4 ESCs, even that have an 80 amp limit on them, and ADB, they make great stuff. I hope it's ADB, or is it ABD? I can't remember. But I got everything that I started with, when it came to the flight controller and the power distribution board from Get FPV. They're not affiliated with me. I'm just mentioning it because that's where I got it. Their online tech support is really good. Their texts that come onto the chat, they can help you with just about everything. Except some of my questions stumped a couple of them. And it was because I have a very unconventional project. And that's I'm running this setup off of, and this is a good battery. I love this battery. This is just not going to focus for me, is it? There you go. I probably need to invest in a better camera, right? Maybe a ring light, not like my desk light shooting off at an angle. I'm trying here. Okay. So it's a graphene battery, 6,000 milliamp, 22.2 volt. It is the Yowu, like literally YOWOO. And it's a graphene battery. No matter how many amps I pulled from this, I'm flopping the cord around. No matter how many amps I pulled from this, it never overheat. I mean, it didn't get hot. It didn't get as hot as I thought it was going to get. With the 14.4 volt or 14.8 volt, it was screaming hot. And that was because the higher kilovolt rating was pulling the full 80 amps on the ESCs. And it would also have a shorter runtime. So I had to run a 7,200 milliamp 14.8 volt 4S battery to run this. And that's what I was running when I hit the fence. And it's because one of my ESCs just tweaked out. I think it amped out, and there was a spike or something because my front port bow motor dipped after I tried to recorrect, and then it just kind of inverted and then sliced the motors off the other side. But it was funny. If you haven't seen the video, go see it. But what we're going to do, I think, and I also have, on the next giveaway, I have these. These are awesome. These little 1,500 milliamp Zs. This is a 120C battery right here. You can rip around with these. That'll be on the next giveaway. I'll decide when that will be. But this one, like I said, I'm giving away 2 of these to 2 people. And if you like it, if you want to be involved, Steve, all you got to say is you're already a subscriber, I think. So, so you're already in. If you're not, subscribe, and just put in the comments I'm in, and I'm going to give it a week for people to see this video, and then I'm going to come back same time next week, and then we're going to everybody who's entered their name, said I'm in, subscribed, liked the video, tell your friends, tell your family, tell everyone. I mean it. Tell everyone. It's not a request. Anyway, my point is, let me get some coffee because it sounds like I need some. Caffeine. All right. So just if you like what you're seeing, and you like what I keep doing, like what I'm doing here, if you have comments, if you say, hey, that's a really stupid idea, don't do it, I'll take it into consideration and probably still do it. But I will have considered your opinion because I want the community to kind of get involved. Because there was one person that came up and said I had, I'm not going to say his name, but, because he's trying like everybody else, right? So he said I had, I think he mentioned something, he goes, is this a self-found project? And it's not as if it's a self-found project. I'm aware of these things. I'm sure I know there's other EDF style VTOL systems out there, but mine is to be built to a specific purpose. So, and that will become known in the future. But for now, what he was saying, you made horrible engineering decisions or, on this model. And I thought, how do you know what my purpose is for this stage to call it? I think he used the word pathetic excuse for engineering or whatever. You don't know what I'm building this for. So what did I build this for? I just explained it. It was to get to know how these flight controllers react to the RPMs, the oscillations, the vibrations from an EDF that is literally solidly connected to the flight controller with no cushioning, no TPU thing mount to put it on, nothing like that. Just the bushings that come in the stack. That's it. So, yeah, next Saturday is the giveaway. ERS platform. Okay, yeah. See, that's what I want right there, Steve. Why you gotta do that to me? I only have I've got one kidney left. It's probably worth an ELRS transmitter, maybe if you like rock gardens. But why you gotta say that? Now I want one now. I can't do it. I will eventually. I will. But now they do have a few on Get FPV I was looking at, and there was one that was starting off with 139, and it wasn't. I think it was the Radio Master or something like that brand. I don't know, but it was. It seemed like a good deal, and you can get an ELRS receiver. It is ELRS ready, and then I think I'll have a little bit more control. It's got to be better than S-Bus protocol because, and I want to get a GPS module because even though I had no stick movements on the EDF, it would drift if I wasn't putting in stick commands. So, and there was a lot of stuff that happened off camera that I wish I was recording because it was just hilarious when it would happen. Like I had one motor when I had the 6S's in there. And I want to stay with 6S's. I just didn't have any money to buy more or any more expensive ones. I don't know what brand motors people go with the EDFs. I mean, you're looking at a 3060, so somewhere in that area. I don't know what brand to, I don't know what brand's better than the other and where to get it that will fit. I think this is a 5mm shaft, I think, for the EDF blade. I did get a magnetic balancer for those EDF blades. That helped dramatically. But unfortunately, I hadn't done it before I wore the bearings. And I was getting to the point because I'm trying to save money here. I'm like, okay, so if I take this motor apart, clean the magnets off, make sure there's all, everything's good to go. Can I change the bearings out of the bottom and the top? And if you could, where do you get those bearings? Because it's not like they give you the bearing specs. I swear there's no rum in that coffee. The specs on each bearing. Because I could find, it showed the cutouts on some of the pictures on Amazon, because these were Amazon motors. I bought them on Amazon. They weren't Amazon motors. It's like, can you imagine getting an EDF that says Amazon Basics on it? That would be funny. Or LiPo. It's going to happen. It is. But and the transmitter I'm running at the moment is just this one right here. The Skyfly at Fly Sky. And it's not, it doesn't have the best sticks. they're a little wiggly. It's almost like flying with spaghetti, and the funny thing is, on that the first design, the one with the tri motors, my actual lifting motors I had on this potentiometer knob to get the lift, and then I was going to use the thrust, this one for the thrust, and then use the servos and the moving of the motor pods to control it that way. it was a crazy idea because there was just no way I was going to get stable enough with those servos. I would need some digital servos and some other stuff, maybe run it through a gyro. But at that point, the gyro wouldn't know what the heck it was looking for. You know, it would have to be a simple, just a 2-axis, so that you could put the ailerons and the front motor pitch into it. But the problem was you have the yaw of the single motor when you're doing the Y copter. Plus, I didn't want the 2 in the front on the Y to be the forward flying. I wanted the single engine facing, forward. That was the whole idea. But this isn't a bad transmitter. I mean, it's not. It's definitely a decent one, but it's just not ELRS. So, and from what I'm understanding, that is something that I'm gonna want as I proceed, especially when we're dealing with EDFs. Because let me pull over what's left of this one. So, as you can see, this looks like somebody threw away a VCR and the bulldozer went over it, and that's what's left. But I didn't even want to even bother using the LED strip connections here to mess with that. I didn't even want to do that, so I just programmed an Arduino, stuck it on there, and stole the 5 volts from the board, down here. It's been an adventure with this one, but as you can see, I built this very thick, very heavy, more walls than necessary, more infill, really just because I wanted this to be a robust platform that put some stress on the motors, and stress the motors I did, as you can see from most of my videos. Now, this one, if you imagine, you're like, what the hell is that? EDF Jungle Gym? Okay, so these feet aren't supposed to be here in the finished product, but you have battery ports, ESC ports, battery mounts, power distribution board, and flight controller. You've got one EDF mounted low, one EDF mounted up here high, and then one here and one here. Both they were controlled by servos. The idea was this would be the framework internals for a flying wing that had EDF on the bow, EDF on the aft, both port and starboard. And not only would they lift the craft up, but they would rotate it forward, and there wouldn't be any control surfaces on the wing. The control surfaces wouldn't be necessary because the same servos that rotate forward from drone mode would also pitch opposite each other, just like an aileron. And I wasn't sure how effective that would be, but that's why I wanted to try it. But I haven't finished this one yet, because I need a better printer for the printing a larger wings, a larger surface area for the wing. And also, I found out the hard way how unbelievably difficult it is to cut carbon fiber rod. I mean, I'll just get a pipe cutter. Put it on there. Well, that didn't work. Oh, finally had to. I was literally just at jigsaw, And then I saw this cool little like electric cutter, shop cutter for stuff like that. So I may end up getting one of those. But the idea behind this one was it was an internals airframe. It's very lightweight, but would hold everything you need. Literally, the motor pods sat between a servo and this point here, and the servo would rotate them around this axis, and then you sort of get the idea. So you'd have one down here, and then a servo would go here, and then the motor would go here. Same thing up here, and then on each side. This would be a servo holder, this would be a servo holder, but I broke it off. So, really just experimentation in design, just to, I guess I'm the type that I like the way the rapid iteration of experimentation. So, okay, I have a change I want to make. So I'm going to make it, print it, try it, see if it works. I can crunch the numbers, but sometimes the numbers don't give you any real data outside real world applications. They can get you in the ballpark, but you really have to try stuff out. And the reason for that is because if you're depending on qualities of motors, if you're depending on qualities of batteries, your power supplies, things like that, the numbers might say one thing, but the actual performance might say another. And that was what I found out, especially when I started losing one of these motors because of the stress I was putting it under, and with an unbalanced EDF blade, it basically wore the bearing out. So what was happening was I wasn't getting the full RPMs, but a full undisturbed RPM out of the motor. And it would sometimes yaw by itself to the point where it would yaw. Like it would literally I'd come down and do a full 360 degree, and then I would recover from it. And it was because I was putting a lot of yaw into it to recover from it. Because I wasn't getting the RPMs, the consistency of the RPMs from each motor. So what really matters to me in my final build of this, because I'm going to do this again, but I'm going to try and do it with 90 millimeter instead of 70, because I'm running 6S motors. So if I ended up deciding to run 12S or even 8S, it wouldn't matter. The biggest problem is finding clockwise and counterclockwise rotating EDF blades that are consistent. Now, JP Hobby has them, and again, they're not affiliated with me, but I'd like to mention them because there's a machined out of aluminum, and they look beautiful, and I'm sure they're balanced perfectly. And that's really what I want to get. But at $306 for 270 millimeter, and those are the only two that I could find that are paired with each other. They're paired with each other to be counterclockwise and counterclockwise rotating, which is what I'm looking for. I'm going to have to buy 2 sets of those. So that's $600, over $600 with shipping right out the door. I've got to buy 380 amp ESC D shots. That's going to be roughly $200 just for those two, 230, 240 just for the ESCs. The power distribution board that I have was $80. The SpeedyV flight controller, those are only about $40. So that's not bad. I can reuse the power distribution board that I have. I may get another one just because I want to make sure I'm starting fresh, but I'm sure this one works just fine. I need to learn to solder better. That is for certain. Because I'll just show you. And I do need to get some different solder ends, and I do need to get some better solder. What's the best solder for this stuff? This is horrid. Focus. Yeah, you see that? I'm surprised anything works on here at all. It's like, yep, I'm connected, barely. Like a thread. And then my poor ESCs just literally completely torn up. Just giving up the ghost. They're ready to just quit right now. I mean, one of them's already malfunctioning. So, but I like this particular platform. Can I thin it up a little bit? Yeah, sure I could. Absolutely. And I probably will. Oh, hold on. I want to read what Steve's telling me here. A JR module. Oh, okay. He's talking about the counterclockwise. Hold on. Yeah, no, I get that the counterclockwise is just how you wire the motors. because you can flip them in iNav or you could just do it manually. I've had that experience. But what I mean is the blades. You can rarely find counterclockwise rotating blades as opposed. You can't find the opposite. Usually they're all counterclockwise, I believe, for the most part. It's the clockwise rotating ones that are hard to find. And the company that sold these motors, it's, I believe, a Dobo or something like that. You find them on Amazon. They were the only ones that I found. The plastic injection molded EDF blades that were both clockwise and counterclockwise. That's the only reason why I went with these motors to begin with, was because of that. I didn't care about their housings or anything like that because I knew I was going to end up taking the tabs off and directly sealing that to my 3D print for my motor module. But really the only reason why, like I said, I went with that was because it was the only ones I could find. I searched high and low. Now you can find, stuff that's 40, 50 millimeters, stuff like that. Like you got a 50 millimeter. There's a guy out there that has a 50 millimeter EDF drone that I'm sure he's running off of a small flight controller, but it doesn't have the amp requirements that mine does. So I think it's 40 millimeter they was running. But I mean, he zips around with it really quick and they're really close together. So that doesn't work for me because payload is what I'm looking for, which is why I designed this beast. The idea behind getting those counterclockwise blades, that's the problem. It's just who makes the blades clockwise and counterclockwise. And that's where you're really limited, because I've scoured the internet and maybe I haven't looked deep enough, but that JP Hobby seems to have it because they specialize in motors that you would typically use in a dual motor scenario. And that's why they have a counterclockwise and clockwise rotating one, because they want to make sure that they are not having to worry about yaw at all, so that the performance of their motors is seen more than having to compensate for yaw, which I get. Why that there's not very many companies doing the clockwise rotation or counterclockwise rotation, or vice versa, I can't remember which one's more prevalent. Why they're not making those blades is a mystery to me. And why they're not very many. And I mean, when I ordered it, even through Amazon, it still had to come from China. So, what do you do from there? You're either gonna try to invest in an expensive liquid, resin printer, or a small liquid resin printer, hope that the resin you get can handle the stresses. But it's not. It's just not going to work. For the injection molding on the plastic blades are really the way to go. You could probably print your own, but I guarantee you it's going to rip itself apart at a certain RPM. And these were rated at 59,260 something RPMs, somewhere around there. And and then everyone asks, why are you doing this? Why not just do this with regular motors, regular propellers, and make your drone? It's like because there's a major difference between what you're seeing here and what my final product is going to be. So it's not something I'm trying to sell. It's just experimentation. It's an idea that I want to continue to experiment on. I can tell you this. Telling your friends, subscribing, and sticking around, you're eventually going to find out that one of these days I will be riding something similar around. Yes, I have life insurance. No, I'm just crazy, I guess. But I'm basically making one the size of a quad, and you know, a regular ATV, not ATV, ATV would be 3, right? A quad, like a dirt bike. So that's the size I'm going for. Plus, I'm also experimenting with different power generating options. I need something that's lightweight or comparable to the weight of the battery that I have, but has more power dense. Um, I'd even contacted Beta Voltaics about batteries, but apparently nuclear batteries aren't allowed for civilians. Anyway, I designed one based on Beta Voltaics, a battery that would run 22.2 volts literally for all 12 years. That's at 500 amps constant current. And it only took a fairly small amount of tritium to make that happen. So the design's there. It's just the availability. It's like, he's a civilian. Why are we going to let him get this stuff? It's like, look, I'm not doing anything except I'm experimenting with a propulsion system. Now, there's another option out there. It's a hydrogen fuel cell stack, but you have to understand how much those weigh. But if you're only trying to get a specific amount of volts out of it at a specific current draw, then the cell could be customized to be roughly the same size as a battery. But then you have to have your hydrogen fuel supply. So the scale up would take care of this, because then you're dealing with bigger turbine designs, bigger EDF designs, designed to lift hundreds of pounds rather than pounds. Right now, I'm pushing around 20 pounds of thrust with that system. With the 6S battery that I had in there and the 6S motors, it weighed roughly 6 pounds the way it sat. So realistically, the idea is power density is one of the things that we need to study and experiment with, whether that be hydrogen, whether that be beta voltaics, whether that be the graphene battery. I'm going to tell you right now, did not have the spikes that I saw in the standard lithium polymers. I had way more stable power with that graphene battery. So that's a step in the right direction still. However, the flight time isn't that much. You're looking at 4 to 5 minutes. One of my videos, I flew for roughly 5 minutes on flight time. I wasn't pushing it too hard. It's when it's the battery voltage, your runtime drops, especially with EDFs, the more currents you're drawing, obviously. So you could stay at a stable hover probably for 10 minutes. But when you're pushing those engines hard, that's gonna drop your time. So which I'm sure most FPV pilots deal with. You know, how much power density can I put into this thing and still rip through some places like I've never seen before. I swear, it's like every time they turn a corner, I think they're going to hit something. I mean, if you suffer from anxiety, don't watch those videos. Okay? Not without take like a melatonin first. And then watch that video. You won't be so hyped up. Don't take any medical advice from me, by the way. Obviously, that was a joke. Melatonin sold over the counter anyway, but you got to be careful with it. Be responsible. And I don't know how they do it. The reaction times of some of these guys. I mean, isn't there a delay between the camera and the FPV goggles? And they're like going through like you see this huge door and a little tiny keyhole, and all of a sudden, right through the keyhole. And you're like, how did he get through a keyhole? And then he's like, up, straight up, through a hole I didn't even know was there. So it's like, how do you know it was there? Did you just take a guess? If it was a solid ceiling, is that it for you? Or do you just change directions? I have to buy like a tiny, I don't know what's better to start with when it comes to FPV, like a tiny whoop or what, but I'm telling you right now, the moment I go into FPV mode and I'm like, I want to do something fun and fast, that's going to last for about 25 seconds. Okay, that's about it. Get off the table. Um, the cat likes laying on my printer. You know, this has been an awesome project. I know I'm getting off track, but this has been an awesome project for me. This giveaway is an appreciation for the people who got me over 100 subscribers. And I know that doesn't sound like a lot. It doesn't sound like a lot, but it's a road to where I want to be. And this kind of content is what I want to produce. You know, and I do play games too. If you guys say, hey, yeah, we love the drone, but I love playing Star Citizen. I don't know why. That's the game you love to hate. And it's just because it's an alpha and it's still in development. And yesterday, my character got out of its bed in Area 18 on ArcCorp, and I fell out of the building through the wall all the way to the planet surface, and I was like in a high rise or something. So yeah, that kind of ticked me off because I had to buy all my gear again. But Star Citizen's a good one. I love playing that. So there'll be some videos on that. There'll be some videos that I still use my Mavic to try and shoot some videos. I'm not a cinematographer by any means, but I do love that first person of places that are hard to get to. So I'll do some videos on that, and that'll be in that playlist. And this drone concept that I'm working on will be in its playlist. And then I might do some COD again. I don't know. I liked playing Call of Duty. But much like World of Warcraft, it kind of went sideways. Too many expansions, like too many changes. At one point, I thought COD was turning into just a different kind of Fortnite. You know, it had super characters and superpowers and stuff. Let's get down to the nit and gritty of it. It's just dirt and war. That's what you wanted. Instead, they went, but I'm old school. I'm old school when it comes to COD. I mean, it was just because we were playing networked games before there was an internet like we have now. We would literally bring in a internet switch and hook up 4 of the first Xboxes and have 4 people on each one, and that's how we would network play. That's the old school way of doing it, and it was fun. Everyone hated me because I was always the sniper doing headshots. You can hear guys from the other room, stop it, yelling at me. It's like, that's not fair. But now it's just huge maps of just changes and snipers and sniper glints and now hackers and stuff like that. And it's like, we didn't have to deal with that before. You know, that was... Anyway, I'm going to off track again. The ADHD wins again. Anyway. So I won't be much longer. I'll basically just reiterate that for these batteries for the giveaway here, same time next Saturday, 6 p.m. If you're in it, if you're already a subscriber, you're already in it. If you're not a subscriber, subscribe. If you are one of the few who don't want to subscribe, but you like the idea of being in the middle of a giveaway, I may accept your entry as a comment of I'm in, and just share the video and like it. You know, you don't have to subscribe. Maybe I don't want you to. Maybe I don't want your dirty subscription. You know, but that's all right. I get it. Hopefully we can grow this channel some more, and I'll be doing some more crazy stuff. Like, hopefully not slicing any more drones in half, but I'll definitely be bringing some more content that'll be more fun. Again, if you like Star Citizen, if you like gaming, I'll get into that too. This project has been eating up my time just because I tend to hyperfixate on stuff like that. So, but I enjoy it. What was that, Steve? Experiment with hover to forward flight transfer. Oh no, you know, that's one of the things that I actually was trying to learn on iNav, because one of my setbacks was I was working with iBus S-Bus, iBus protocols. So I was having difficulties with transition from hover to forward flight, if that's what you're referring to. Yeah, if that's what you're referring to, then I had some experience with that. Jacob, hold on, Jacob. I'll get to your question in just a moment. I had experience with the forward flight motion, but it was confusing to me because not knowing iNav as well as most people do, I was like, well, where do you put the transition in? Is the transition after the switch and on the other profile set, or is it in the profile set previous to where you want to be? That was my confusion. And I thought I was going to have 3 presets, because in order to make the aileron thrusters move, opposite each other, you had to hook them up a certain way and program a certain way. It wasn't just like the old school S-Bus hookup where you've got 2 servos moving different directions because of the way they're mounted. It was more or less, I wanted them both to transition forward, but then I both want them to act like ailerons as well. And with the middle engines, I want them both to rotate forward, but I want them to act as pitch as well. So that was really the idea behind that. So no, I don't have too much experience with transitioning. I did set a fail-safe. I tried a fail-safe, and the fail-safe didn't do anything, so it caused it to crash. I'm like, because I'm trying to set up a low voltage fail-safe, and I'm probably, without ELRS, it probably won't work. But I tried to set up a low voltage fail-safe, and I'm like, okay, well, why is my fail-safe a switch if it's low voltage? So, okay, fine, I'll flip the switch. Flip the switch, the drone goes, flips over, cracks, But, Jacob, my job, what is my job? I am a veteran, a retired Army. Currently an undergraduate for engineering at Liberty University. And 3rd year, I think I'm 3rd year. Can't remember. All I know is the math is relentless. I mean, I'm doing math 128. I got 131, 133 coming up. Things like that. Hi, Blueberry. What are you up to? You having fun? I bet you're playing Creatures of Narnia or something like that. Scenario. What's that Roblox game? I forget it. Okay, yeah, I am 3rd year. My wife had to tell me, it's like, you're a 3rd year undergraduate. I think you'd know that. But yeah, I'm basically just going for Jacob. Sorry, I'm going for a bachelor's in engineering because I'm hoping to get into some experimental propulsion. Because I'm going to go for aerospace engineering after that, and then there's a lot, and everyone says, well, why are you doing this when you're older? I was like, well, because I have a lot of time on my hands, being, retired Army. So I just, why not, right? Why not educate myself, have some fun doing it? And I also want to make sure I have options in the future. Who is that? That's Sturby fam. Hi. Oh, okay. Yeah. You changed that's your YouTube name. Hi. How are you, my dear? See, I'll get confused with this stuff because what I have to do first is I got to bifocal it, and then I can see what's going on. Okay. And everyone's like, why don't you raise the size of your font and text and stuff like that? I guess I'm just stubborn that way. I don't want to have to admit that I need these. Oh, yes, Jacob, I'm sorry. I didn't see your question there. Yes, I am American. I'm very American. Very Western. Born in the West, raised in the West. My grandma was from Oklahoma. You know, can't get any more Western than that. Yes, Steve, that is very true. Never too old to learn. Never too old to learn. I had one person ask me, they go, aren't you concerned? Because I was holding the drone at one point. And I was running up the motors trying to get it to hover. And they're, aren't you concerned about your fingers? I'm like, well, I've got 10 tries. He's like, just wear some work gloves. I'm like, well, I don't want to damage the blades. See, it worked. I got it to work. Yeah, it was. So I'm sorry, I'm just going off on tangents. It's fun though. It's my first live. I'm trying to have fun with it, you know. Again, if you are just joining us, make sure you are subscribed. It's easier on me to find out, you know, who you are. And we're giving away 2 of these. Anyone's into to FPV. Honestly, I'm gonna ask you this question because I don't know. So you're looking at 14.8 volt, 850 milliamp ADC. What kind of drone would you use these for? I'm serious because I don't know. I don't know. I bought all kinds of different batteries for the purposes of trying them out. So these have been cycled maybe 2-3 times, and they're on a storage charge. And you can tell that they're nice and flat, no bubbling, brand new, no scuffs, stuff like that. 1 or 2 of them might have a little Velcro strap on it, but other than that, yeah, you know, they're good to go. Well, I love you too, Sturby fam. At first, I didn't notice your accent. Oh, I see. I understand. Yes, very American. And thank you, Sturby, for the congrats on the 100 subs. I love it. I love doing this. And I'm not doing this because of, you know, I want to be right. I don't want to be like who's that guy? Has like every subscriber in America, Mr. Beast or something like that. I don't want to. I'm not looking to go that route. You know, I'm wanting to share what I find out. I'm wanting to share the journey. Is what I'm trying to get at, because it's fun. You know, it's fun to do the unconventional things because these unconventional things lead to discoveries, and sometimes that's how we move forward in technology. That's why I'm studying hydrogen fuel cells. That's why I'm studying beta voltaic systems. It's why I'm studying, you know, how do I get the right amount of current? You know, how can I get more milliamps out of my system than it can produce? Now, it sounds like an impossible task, but I mean, if you can take a 9-volt battery and put it in a stun gun and knock someone out, anything's possible. Because we sat as youngsters like all day long. Just, is this one charged? Not, you know, it didn't knock us out. But when you put one of those in a stun gun now and do it, that's it. You're done. You're over. It's like you're taking a nap. So if we can do that, then I should be able to do this. Right? Who doesn't agree? So Steve, that's a good point. That's a good point. That's a very good point. I had a lot of dealings with ordnance, which is one of the reasons why I joined the military. I liked building rockets and blowing things up. So that's how I got in. So yeah, I guess I'm doing pretty good when it comes to, you know, things like that, because they're all there. Of course, the picture. Now, I don't know if anyone saw the picture on the live on this. I tried to use AI, and you know, I think artificial intelligence. I think these things are going to be smarter than us, and already are smarter than us. They're just not sentient or self-aware, and that's up for debate. But some of these AI image generators frighten the living out of just. They scare me. Okay. Did you see the picture? I mean, I'm like, I put in the specs of the picture that I wanted. Not only did the guy almost look like me, which scared the crap out of me, he's got like extra fingers over here. There's hovering batteries that look like huge double A's, like they're ready to attack me. I'm like, what the heck, man? You're an AI. You didn't understand what I was saying? Yeah. It's to be expected, I guess. Every time I use my voice to text on my phone, I end up saying stuff that gets me in a ton of trouble. We'll save that for a later live. Yes, that's right, Steve. That is right. It's where a lot of radiation came from, too, for a young man, I think, back in the 80s. We all remember that story. Guy's making a nuclear reactor in his shed. Just no safety precautions whatsoever. You know, it's like, but I mean, he did it. You know, regardless of how restricted everything was to make something like that, he made it happen. And that you got to hand it to him for that one. You really do. No heating batteries. Yeah. Well, to make sure that I don't eat batteries, I'm just kidding. I wear a muzzle. The next iteration of that, man, sense of direction is all twisted around this way. My next iteration of this is going to be a total reprint. It's going to be printed a lot lighter, a little bit thinner. We're going to stay with the same battery, same 6,000 milliamp. I'm going to go with hopefully a better motor. If I could save up for those JPs. And I want to go with 90 because 70 is great. And if I have to stay with 70, fine. If I can't get JP Hobbies 90s and clockwise and counterclockwise, then I'll stay with the 70s. But I think when changing those to those motors, not having to worry about balancing because I was too ahead of myself and just didn't balance blades and put them on different motors. I think that'll be okay with just those there. I'll be great with the JP and the ESCs, the D-Shot ESCs for sure, because that's going to help greatly increase not only my data collection from the actual design, but I may incorporate some kind of shock absorption. But for me, I had thought, okay, let's print a TPU bed that and it doesn't have to be very thick. You know, you want to make it thin. Just a thin TPU bed or layer that your flight controller sits inside the 3D printed mount. And I thought that might help, but it also made me think, if it isn't directly attached to the body, is the vibration just going to shake the weight of the controller on the TPU like something sitting on top of Jello, you know, and you just go boom, and it's like all over the place. So it's either it's going to be rigid enough to where it can take the oscillation, dampen some of the oscillation, but not affect the flight control itself as far as its orientation and it thinking it's getting thrown all over the place. Or do I just forget that altogether and make sure that it's mounted directly to the body, and that the stack itself, the gyro that's in the middle of the stack, because it's held up with little rubber stoppers anyway on that F405 wing. So that seems to be the only stabilization I believe that they're looking for. I don't think you need too much stabilization. I think what I really need to do is just make sure that I've got the black box information so that I can kind of adjust that gyro frequency or the gyro, the LPF cutoff frequency of the gyro to kind of help with any kind of oscillations or anything like that. And then it's back to the drawing board with the PIDs. You know, you've got to, once you've stabilized that, once you've found out what you're looking for on those frequencies, you've got to go back and then redo the PID all over again. So it's back and forth with the PID. You get to a certain point, you're like, everything's flying great, and then you think maybe I can make it a little bit more stable. You move one little thing, it's completely out of whack, and you're like, I gotta start over. So you got to like reset them back to the, and then they're not acting right because after you did that, you changed your gyro filter settings. So it's like now you're like, oh man. So I've got to figure out how to save those settings, like when it's flying really good, to save those to a file, then mess with it. And if I screw it up and it's dancing all over the place, then I can go back to those settings and change something else. Oh, it is a trade-off, Steve. So I'm not the only one. So to be exact, you restrain. So you, yeah, I have to restrain from eating batteries. Come on, who eats batteries? Except that thing right there. I'm telling you. Heat is one of the other things. Heat is definitely one of the other things. I'm realizing that the shorter the cable from the battery to the input on the power distribution board, and if it's at least 8 gauge, it can handle the heat. XT90 connector, because I want that bigger, robust connection. If I'm staying with lipos, obviously I'm going to be staying with lipos for a while, but yeah, definitely 8 gauge wires. And even with, I mean, I only had an XT60 hooked up to it, to the actual board. So I had this little converter that went from XT90 to 60, and they came together. I don't even know why I bought them. I had, because I guess, well, I know why I bought them, because I didn't have any female XT90 connectors. So what I did was I got the Amazon version of them, and they're like literally like this, but they shrink wrap them. And what I did is I undid the shrink wrap, and I saw how much solder was between the 2 points, and it wasn't very much. So I added more, made sure it was, you know, really robust, insulated between the two to make sure that there was never any arcing that was going to happen. And then I just put some electrical tape around it and made it a little bit more robust of a connection. And it doesn't overheat to the point where it bends or flexes or anything like that. It's actually works out really well for that 6,000. And this is a 100C battery. I'm wanting to find a 150 6,000. I designed the case here to hold a 10,000 milliamp, and I lifted a 4-pound book with that off the ground fairly easily. It wasn't really stable because I kind of just threw the harness together, but it lifted it off the ground and flew on 6S. So I know it's, and with this battery being roughly 2 pounds, you know, the 10,000 is probably going to be 3, roughly 3.5. If I can lift 4 with that easy, then the 10,000 is going to give me a heck of a lot more flight time. And I know everyone thinks crazy. They're like, 10,000 milliamps. What are you running? I mean, it's like I'm drawing 340 amps constant current with the 14.4. 200 what is it? 66. 248, if you want to be somewhere around there. 248 with the 2100 kilovolt 6S motors. So the bigger the motor, I get more torque. And I draw less current for the same RPMs. Somewhere the math doesn't add up on that one, but these ended up working a heck of a lot better than the 14S. 4S 14.8 volt. You know what I'm saying. All right. Anyway, and that's why these never got to work out. That's why they're basically brand new. That's why I'm giving them to somebody who can use them. You know, I wasn't trying to buy subscribers, but I sure was trying to get your attention. And lipos are expensive. So who couldn't use a basically brand new set of lipos for nothing, right? That's what this giveaway is all about. So anyway, I've enjoyed talking to all of you. I'm glad people that are here are here. I welcome all of you. If you have any questions for me on anything I've done in any of my drone videos, feel free to ask. If it's not right at this moment, I totally get it. I'm looking over. I'm trying to make sure that I'm not missing any questions. Oh, Jacob, sorry to see you go, man. Thanks for stopping by. I appreciate it. It seems like some of the people that are my subscribers are overseas or on the East Coast. And I'm not sure how many are on the West Coast, to be honest with you. Oh, rain possible. Oh, that's typical. We've been having some serious weather here that has been highly unpredictable. I mean, it's the 6th of April. It's only 57 outside. It was 38 last night. But no, you can't make a milkshake out of the batteries. Sorry, Sturby. That would be bad. That's one of the main things that scares me about overamping these lipos is you can cause a lipo fire and those don't go out. They burn out. I mean, anybody who's seen a Tesla burn knows that. You don't put those out. You just wait until they're done. So yeah, I got a bag to keep all my lipos in for safety. So next week, same time, we will be here again, 6 o'clock Pacific Standard Time. And I will make absolutely certain that I have a list of everybody that's subscribed and everyone who is interested in the batteries. Make a comment in there, say, yeah, I'm in for sure. I'm just comment, I'm in, or subscribe. That's the easiest way for me to figure out if you're interested. And then I will be giving these away. After that, after these, there's going to be 2 of these to 2 other winners. And the reason why I'm doing that is because I'm trying to, the YouTube community has given me a lot of information to get me going on this project. I've asked a lot of questions. I've gotten a lot of great answers from people who know their stuff when it comes to these videos, or not these videos, but these drones applications like this. So when I throw a question at them, I'm like, I'm running EDFs, and the first thing is like I get a question mark, but they know what I'm doing. So I'm just trying to give back, and it doesn't do me any good to hold on to these if I can't use them, because I don't plan on using them in the near future. So I don't want to hold on to them because I don't want them to just sit around and go to waste. And send 2 of them out to each winner and let them have fun on the drone that they use them on. Again, did anyone ever answer that question? Did I miss it? What drone do you use a 14.8 volt, 850 amp ADC on? What size drone? I'm curious about that. Like if you got these 2, and I sent them to you, well, what drone do you have that you'd use it on? I mean, what are they good for? They're made for a specific purpose. So, anybody want to answer? No, not yet. Okay. Well, I will look at all the comments, over the week to see how things are going. If you're able to come back, and if somebody sees the video after the fact, still wants in. Subscribe, like, share. And I will be back the same time to get you guys. We're gonna put the names in a hat, and we're just gonna. I'm just gonna right here in front of you. Drama. I don't know how to set up a digital thing for the giveaway, so we're gonna go old school. We're just gonna write your name down. We're gonna pull it out of a hat. All right. Gonna be a lipo bingo like crazy around here. So. All right, and thank you all for being here. I appreciate it. I appreciate you making it a good first live stream. I enjoyed it. I enjoyed being here. I'm glad someone's here. Thrilled that someone's here. You know, and later on, gonna be bigger giveaways. Bigger giveaways. Like full monstrous pieces of crap giveaways. All right. You know, once I get to my other stages. So thank you all for being here. I love you. Thanks for subscribing. Thanks for supporting me. Love the YouTube community. You all have a wonderful evening wherever you are. Stay safe. God loves you.